Hi, my name is Mahesh Balasubramanian. I'm the Director of Product Marketing for Instinct and ROCm at AMD. And today it's my pleasure to have Rajat Monga from Microsoft, who is the inventor of TensorFlow and the CVP for AI frameworks. Rajat, thanks for joining us.
Thank you for having me.
Rajat, let's start with open. You worked in the industry for a long time and you understand the ecosystem. What does open mean to you?
Yeah, so I've been in the industry for a long time, like you said. In fact, I started in the space around 2011 or so. And at that time, open was, okay, let's publish papers about all the research that's going on. And of course, the reason to do that is none of this happens in a vacuum. A lot of the research is happening in the open where people are building on each other's research and so on. And over the next few years, we continued to do that. We built on other stuff. We published a lot of our papers, a lot of our work. Around 2014, 2015, we realized that, this is great. There are some software that people are using, and we had our own at that time I used to be at Google, and we had our own internal thing called Disbelief, and we were building a new one called TensorFlow, and we decided, if we make it available, it might actually help speed up things, make things available to more people rather than just the researchers who can look at the papers, right? So that time we open sourced like the software itself, TensorFlow in this case, and help people really build on it. What that changed, I think, was not just that the research became faster because more people could now just take the paper along with an implementation of it and do it, but also that developers could take it and apply it, include it in their applications and so on and so forth. So that was I would say a shift. Fast forward a few years and things have been, continued to grow for AI. AI has really changed over the last decade as well. And, what we're seeing is, of course, the software is open. Everybody assumes that is. But as you go to the larger and larger models, we are starting to see a mix where there are these lots of models that are available in the open source, some with mixed licenses, and people can, think about, okay, how open is that? And some super large ones that are not open, that are more proprietary. And of course, there's the question around, should they be open? But there's a risk because do you want a powerful model like that to be available to everybody? Or do you want some more checks and balances on it? And then there's, of course, the openness in terms of the models that are actually open and openly available. How well can others use it? What does it take for them to use it? And there's some interesting questions there that we are still evolving through. But it's definitely an area that I would say has helped AI go much faster than it was going earlier, and it's been a great thing for the industry.
Yeah. I like the answer, like how you said it, that having this open ecosystem builds momentum, accelerating innovation much faster. And we truly believe in that as well from our side as well. As it's to truly have AI be pervasive, having this momentum behind it is probably very helpful. I have another question for you. So you mentioned about various different models that are being built, and we see this, that there are models that are much, much larger and trillions of parameters to really small, like several billion parameter models. What's your take on how these model development goes and how this model, various model sizes help come to bring to fruition the different use cases of AI?
So as we are evolving, one thing that folks have realized is the bigger the model, the more data that you can train it with, both seem to help. And we continue to see that. There are scaling laws that show that. Of course, you need a lot more compute to be able to do that. But if you can, then we've continued to see improvement. We are perhaps getting to a place where it's getting harder, but it's still possible, right? We're seeing that. And so we see that continue to grow and continue to help, both on the open side, again, where we're seeing some of these happen. Now, to make this happen, of course, we need improvements in compute, which we see, AMD is a leader in that as well, along with a couple of others. But there's also the software stack that needs to grow and evolve to be able to support these models, not just from a training perspective, but inference as well.
Yeah. AMD has this vision that we want to help bring the best product to the market that helps AI innovators like Microsoft build solutions on top of it. And you mentioned about training. Can we talk a little bit more about inference as well? On how do you see this inference needs growing? And what's your experience with using AMD solutions for training or inference and the ROCm software stack and how it enables you to achieve your goals?
Yep. So look, inference, while we talk a lot about training because training these large models is hard and expensive, in fact, it turns out that once you've trained the model, and only a few folks are going to train super large models, most people want to use that model. And so that same model gets used for a long time by lots and lots of users. So effectively, the compute used for inference is often at least as much, perhaps even more, depending on the models, depending on what we're trying to do. And so it's valuable to really get inference right, and it has to be efficient. The cost, over time, it's gone down significantly, partly because of the software, the hardware, all of those coming together, et cetera. So talking about AMD and our experiences, at Microsoft, we've deployed a lot of AMD GPUs. And, we've had a great partnership with AMD in making that happen. The ROCm stack, I've seen that grow from literally, when it wasn't around to where it is now. And it's amazing how far it's come. We went from a model that was running on a different architecture to this in a few months at really good performance, right? The hardware is great. We're seeing chips that are very competitive and very usable. And with the software stack coming up and continuing to grow, this has been great. The partnership as well is nice in that, as we continue to push the boundaries of things, occasionally we hit rough spots, and the teams have been great in supporting us and working with us and continue making that happen.
It's good to hear about the partnership and the joint effort. And it's also great to hear your experience about, how easy it was to use AMD solutions and to start using our software stack as well. So last question from my side, putting on your visionary hat on where things are going to go in the future, what can you tell us about, what are we looking for in the future without giving, any proprietary details you might not want to give us?
Yeah, there are a few different directions, but let's take the top two in some sense. One is the research continuing to grow. We're talking about bigger models helping. And while there's talk about, okay, can we really do that? Do we have enough data? It does feel like there are probably, as they call it, a couple of turns of the crank in some ways that are still left out there on the current path.
Right.
Will it need new technologies? Perhaps, but they're more iterative, right? And will we hit some bottlenecks? We'll know, but for now, it seems like in the right direction. And every time we've done that well before, we've seen a significant improvement in the capabilities of the model. Do we know exactly what they're going to be? Not quite, but we definitely see improvements every time in XR. And the other thing, I guess, is really applying these models. So we talk about, the reason we build these models is that we can have real products, real use cases that lots of folks can use. And, at Microsoft, we've done a lot with copilots and making people more productive with AI under the covers. So we really make AI more friendly for the end user, right, who is using us. And we continue to expect to see that. This is, early days. We talk about things like agents, et cetera, happening, which are, taking some action, small actions on behalf of the user, et cetera. So some of these fields are expected to grow, and I think we'll definitely look to see more of that happening over the next couple of years.
Yeah, it seems like we are just in the beginning of AI, and it's very interesting to keep track of all the new research and all the exciting exploration that you guys are doing and what we're able to see the industry is doing. So thank you so much, Rajat. It's a pleasure having you here today with us.
Thank you as well. It's a pleasure.